All right, welcome everybody to the Hack Summer pre-show, which we've started calling This Week in Cyber. We're taking this kind of pre-10 o'clock time to talk a little bit about the week's events in cybersecurity. Have a couple of interesting stories for you this week. Let's get started with a brand new, and this just broke on Friday afternoon, a brand new severe vulnerability on Pulse Secure VPNs. This one has the CVE number of 2020-8218. But let's take a step back first. What is a VPN? You might know, but just in case people don't, a VPN, or a virtual private network, is a technology that allows remote users to tunnel their traffic into another network and sort of appear to all parties involved as though they are part of that other network that they are remotely connecting to. Now, in the age of COVID-19, lots of organizations are using VPNs in order to manage their remote workforce. So for example, you're at home, you need to access content on a local file server at your office or something like that. You fire up your VPN and it looks to both you and to the devices on the office network like you're in the office. You have an IP address that looks like that. You can touch the same assets that you would as if you were on site. Now, there are many different VPN technologies, and one of them is known as Pulse Secure. They're a vendor that creates VPN solutions. Now, back in, I believe it was October or November, we had another severe VPN vulnerability from Pulse Secure that led to remote code execution. And here we are again with yet another RCE vulnerability. A remote code execution vulnerability is a vulnerability that allows an attacker to send tailored requests or commands and have code like shell commands that we've been doing on the bash shell executed on the target device. And so this is really, really dangerous, obviously, because you can get the device to download malicious software, execute malicious software, or disclose sensitive information. VPNs are a massive attack surface area that organizations need to worry about right now. In addition to the two Pulse Secure VPN vulnerabilities, actually there were more than two. In fact, this disclosure includes this CVE 2020-8218 as well as 8221 and 8206. So they kind of came in a bunch. In addition to the two Pulse Secure disclosures, we also saw a Citrix VPN vulnerability earlier this year. Well, actually in December, so at the very end of last year. And that was CVE 2019-19781, which again led to remote code execution, or could lead to remote code execution on the device. So if you do work for an organization that uses VPNs, you want to make sure that the people maintaining those systems are updating them frequently, especially this last one, since the news did drop on Friday afternoon West Coast time. And so if you were to the east of us, then it was well into the weekend for folks. So just something to keep an eye on there. The next story is about the dark web, which is a topic I both love and hate talking about, just because it's so grody. It's really kind of nasty, the stuff that goes on in there. But at the same time, it's this kind of, the cyber underworld, and there is something kind of exciting about the fact that even exists. I sometimes joke that we have achieved the worst of our cyberpunk dystopian dreams that we started in novels by William Gibson and folks like that, and this is one of those things. So the dark web, in case you don't know, is a set of connected web servers that do not use traditional IP address, or don't use traditional DNS routing. They exist on something called the Onion Router, or Tor, and which was a technology actually originally developed by the US Navy to anonymize internet traffic. And so if you set up a Tor server, you are working on that kind of independent network rather than the general internet. And you have to use a Tor browser in order to access these dark web sites. The other thing that's often true about these sites as well is that they're not advertised, right? So you kind of have to know somebody who knows where to look, because you can't just go to like evilhackersforum.com or .onion as the actual Tor top level domain is. You kind of have to know where to look, and that can be difficult. And it's difficult not just for the people who are trying to do bad stuff, but it's also difficult for law enforcement to track people who are definitely using this technology for some unsavory things. So one of the most well-known forums and kind of marketplaces on the dark web was known as the Empire Forum or the Empire Marketplace. And Empire recently underwent an attack. This kind of attack was called a distributed denial of service attack, which means that many different computers all at once were sending traffic to the Empire Marketplace servers. And that much traffic brought the marketplace down. It was a sustained attack. It lasted a couple of days. And by the end of it, the Empire moderators, the maintainers, decided that they were done. And so the marketplace shut down, meaning that the people who were there trying to buy illicit goods kind of scattered to the winds, and they went to different places. Now, we don't know necessarily where they went, but it is a major vacuum in the dark web kind of marketplace scene, which may lead to a whole set of new and interesting developments. What are the kinds of things that the dark web is used for? It's used for really, some stuff that I'd rather not talk about on the stream, but we definitely do see instances of, people attempting to buy weapons, buy drugs. And importantly for this conversation, people use the dark web forums and marketplaces to purchase hacking tools and hacking contractors. So people, I shouldn't use the term hacker, cyber criminals is what they are. And people who are willing to pay for cybercrime go to these marketplaces to acquire talent. So it's a really kind of gross place to look as part of the internet. It's where you want to go if you don't want to be found. Now, there are perfectly reasonable arguments for anonymity, but what we do see a lot of is that the dark web is used for criminal activity. All right. Anything else that I needed to talk about the dark web? Anybody can get on it. I should mention that if you are interested in playing around with it, what you would want to do is download the Tor browser. And I'm not advocating crimes, but it is interesting to see how Tor works from a technological perspective and how your traffic is anonymized going from place to place. You can imagine some perfectly legitimate uses of Tor. So, for example, in countries that have an authoritarian regime in power, and you don't want your internet traffic traced for the state to understand what kinds of content you're viewing or communicating with your resistance allies, things like that. Tor can be used for that as well, and that's not, that's a noble end of anonymous internet traffic rather than illicit. So it's a great technology from that perspective, but unfortunately, like everything, right, every tool, we see that it can be used for both good and bad. All right, so that's the dark web, and that's our stories for this week in cyber. So let's get started. Welcome then, friends, to Hack Summer. My name is Taggart. You can find me on Twitter there at mttaggart. If you haven't yet, please give this video a like and subscribe to the channel. It helps me out and helps other people find this content. If you're finding this series useful, I really would appreciate a sub. So what are we doing here? We're talking about Python, and we're talking about cybersecurity, and we're talking about Python through the lens of cybersecurity. So last time we took a bit of a step back from new skills, and even the step back from the practice that we did back. We just keep stepping back. And we talked a little bit about networking. We did a breakdown of networking concepts, talking about protocols, ports, how IP addresses work, and DNS. We even played a little bit with the requests library, the requests module, to make HTTP requests for the in Python. So we created network traffic using Python. And this was all in preparation for what we're going to be doing for the rest of Hack Summer. So for our final sessions, we are going to, from start to finish, we are going to build an app. And the way that we're going to build it, we're going to build it appropriately. It's going to work, but as we build it, we're going to understand that there are some security flaws in what we're doing and how we're approaching the app architecture. And that's important because once we build the thing the first time, we're going to hack it. We're going to learn how to exploit those flaws. And then finally, we're going to fix those flaws. So there was an old Andrew WK show called Destroy, Build, Destroy, which is kind of like they knocked something down, build something new out of the parts, and then knocked it down again because it's fun. It was a great kids show. So we're going to kind of do the opposite, right? We're going to build first, then we're going to knock it down, and then we're going to rebuild it. So you might not think that we're ready to do something like this, but I assure you that we are. We have all of the tools necessary to build an app right now. Are we going to need to learn a couple new libraries in Python? Absolutely. But those libraries are using the same concepts that we've already seen in the Python that we've written and explored. So even though it will feel a little new because you have to learn kind of the shape of what the modules, properties, and methods do, the concepts themselves are not going to be that different. We're going to be using the same 4 fundamental structures of programming. We're going to be using data types that we're familiar with, right? We're going to open files and write to files just as we've done before. So all told, really not that different of a situation. And this is also the part I wanted to call out, that this is the part where it's no longer just about programming, okay? When we're building an app, there are a million different things that we want to think about. And honestly, most of it is a human enterprise, not a technical enterprise. And that's because the tool we're building is ultimately for people to use. So we have to think about people first. In the Stanford Design School curriculum, or the design process, one of the things that they start with is need finding, meaning what is it that the client requires from the solution, and that requires a degree of empathy. So you have to understand what the user requires in order to build it appropriately. You can't just throw code at people. That's not going to work. Design before code is a really core concept if you're going to be a software developer or software engineer of any sort. You have to think about what you're doing and why, and understand that that bigger goal is more important than any specific code task that you are undertaking. So I always like, when I'm designing a new app, I always like to start with a feature list, a wish list of the things that we want our app or our solution to do. By the way, if you have any questions, feel free to throw them in the chat. I am watching the chat live, so if you have questions, I will attempt to answer them as we go along. But yeah, so we want to have a feature list. So let's think about the features for the app that we're going to build. Now, our app is going to be called PyTasks, and that, as that name might suggest, it's going to be a to-do list app. It's not the most exciting thing ever, but one of the things that we like about to-do list apps is that they give us the fundamentals of what we need to learn for software development, right? Without getting too far out into left field with, crazy features. So it's going to be fairly basic, but I'm excited to build it because I think I might actually use it once it's done. What we're going to do is build a command line application where from the terminal on any computer, we could use it to look up our tasks for the day or for the week, however you want to use it, see what's coming up due, what's overdue, and we can use it to track what's done and and then send that data to a remote server that stores the data so we can access it from other places. So yeah, pretty exciting. And so the first thing that we need to think about is what we want the app to be able to do with our tasks. Most basic principle is that we are going to require CRUD operations. What is CRUD? CRUD is create, retrieve, update, and delete. So if you think about any task or to-do item, we have to be able to make new ones. Create, we have to be able to get the ones that already exist from our remote server. That's retrieve. We have to edit tasks, right? Mark them done, change the due date, change the name or description, whatever we want to put in there. They have to be modifiable. So that's update. And then if we want to trash them, or if we decide that we eliminate done tasks for whatever reason, we're going to have to delete them. So create, retrieve, update, delete. That's kind of brass tasks. Brass tacks, not tasks, although I guess that applies too. That's what we start with. But then even in our conversation about that, we might have surfaced different features. So for example, we talked about due dates. Well, we're going to have to track time then in order to do due dates. And how do we tell if something is overdue? We haven't really dealt with dates or times yet, but Python has libraries that make it possible to do so. So we can track what's overdue and what's not. And the other thing we might want to think about is, imagine using this for multiple users, right? You set up a server where maybe your whole family can have accounts on it or something like that. If we want to do that, we have to handle user information, and that gets us into passwords, right? User accounts, things like that. So even in this very basic app, there's going to be a lot going on that we have to manage. It's totally manageable, but it's important for us to think about those things before we get started writing our code. In the design that we've talked about so far, we've already made a design choice, which is that we're going to use a server client model where the data is not going to be stored on your local device. It will be, but that's not going to be the authoritative source, right? There's going to be a server out in the cloud. In our case, to start with, that cloud is going to be Replit, and that's going to be where the task data is saved, and your local computer, your client, is going to retrieve and interact with that server in order to work with that data. Now, why is that important? Well, you could imagine having a client on more than one computer, and let's say that on computer A, I mark a task as done. I want that data to be synced with whatever happens on computer B. So in order to do that, there has to be a single point, a single source of truth, right? And that single source of truth is going to be our server. So we have a server client model, which means we're going to be writing really two very different chunks of code. The server code is going to be much different than the client code in terms of what it does and how it operates. Just noticing that I'm like super fuzzy and I can't tell why that is. Let's see if I can get the autofocus to work a little bit better. Thanks, camera. The other design choice that we made is that we're going to be using a command line interface app. So we're going to be doing this on the terminal. Now, that's because what we've been dealing with so far is text-based programming, right? We haven't really gotten into graphics or anything like that. So that's one of the reasons for that design choice. Also, I happen to like command line interface apps. I find them very handy. So my bias is definitely present in here, but no, that's the way it goes. However, because of the way that we're going to be writing the server code, it would be totally possible to later write a graphical application that connects to the same server and works with it the same way. Because we're going to be writing, we'll talk about this a little bit later, but we're going to be writing what's called an API, or an application programming interface, which allows us to kind of advertise the same communications from the server with many different types of clients. So one thing we might want to start with is the data model. The data model is thinking about how we're going to structure the data that we have to deal with. And think about the data types that we're concerned with when we save that data and when we generate data. I like to think about data model pretty early in the process because it informs where things go in the code. There's another component that we'll do next, which is the flow diagram about how the steps of the application actually proceed. But I like to think about data model first because it makes me start thinking about, okay, what are the things that I really care about in the app? And then once I have those things kind of out there unorganized, I can start putting them in sequence. So let's take a look at a data model that I've kind of thrown together for our app. Okay, so here I am in Replit. Rather than go through the new REPL process live, I kind of made this because there were a couple of documents that I wanted to upload here to my REPL before we got going. The first is datamodel.md. And if you've never seen the .md extension, that is Markdown. Markdown is great because it creates a way of doing formatted text. Look how nice this looks. But using really, really simple plain text as your base. So if I click on edit, you can see this is how I made the Markdown file, right? 2 hashtags for a second level edit heading. Let me actually put in a first level heading for data model. And then preview it. So you can see I've got this nice structured text. It actually renders HTML. That's what Markdown does. I use Markdown every single day. I take all my notes in Markdown. Okay, but I am not sponsored by Markdown. It's an open, it's an open standard. So if you want to use Markdown, I highly recommend it. Now, what are we looking at here? This is just a little bit of syntax. This isn't like real Python or anything. This is just syntax that I use personally to describe the objects that we're going to be concerned with. And to be honest with you, these are likely going to become classes when we write our Python code. So the two big things that we know for sure that we're going to have to think about in our tasks app are tasks and users. So what does a task look like? Well, very, very basically, we know that we're going to have a title. Okay. We know that we're going to have a description. So you could say the title is like take out the trash, and then description might be a more detailed set of instructions for how to take out the trash or whatever you're doing, right? There's kind of the headline and then there's the story. So title and description, we might need both of those. We also are going to have a due date. Now, in Python, the due date is going to be represented as a datetime object, which is built into Python in the datetime module. And we'll talk a little bit about datetimes when the datetime arrives. That won't be today. We'll be doing that probably next week. But I should also mention that when we transmit this information over the network, this is going to change to a different data type. This is going to be a type of formatted string, the same way that these others are. You can see title is a string, description is a string. And then user ID is going to be an integer. So the user ID is a really important relationship because it indicates who made the task. Let's look at user then. So what is a user? A user has an ID, and this ID is going to match up with the task's ID. That is how we're going to give a specific user the tasks that belong to them. You might even be thinking right now, I hope you are, about how we would write code to retrieve all the tasks that we have saved and find the ones where the ID matches. We're going to have a first name, we're going to have a last name. We honestly could do like a username as well. In fact, let's edit that and add a username. That's a string as well. And then a password. Now, a password is a string. We'll talk much more about passwords, as you might imagine, given the theme of this course, but this is what a user object is probably going to look like. So those are the two big things that we need to think about in our data model and what we need to describe. So now that we know that, we can take these two big things and then think a little bit about our feature list, what we want our app to do, and how we're going to make the app function in order to do so. So the next bit of plain text that we need to do before we start writing any code is called a flow diagram. Now, there are 100 different applications that will help you create a flow chart or a flow diagram of your application. And I've used all of them. Lucidchart, Draw.io, Microsoft Visio, Xmind, SimpleMind, all these different mind mapping tools, right? And at the end of the day, and they're all pretty good. They have different features that are really great. At the end of the day, I'm just too lame for any of them. I'm too old school for those. So what I tend to do is I write my flow diagrams in plain text, as you'll see. And one of the reasons is I don't want to worry about what application people I'm working with have, right? If you don't have a Visio license, then I can't use Visio with you. If you don't have Xmind installed on your computer, like there are all these different reasons why I go plain text, but mainly it's because of my bias towards open and simple communication standards. So that is why the flowchart we're about to take a look at is in plain text. So I hope it's easy enough to read. If not, I apologize. All right, let's take a look at this ASCII art flow diagram. Oh, good God, it's terrible. Okay, there we go. We just needed a wide enough screen. So what are we looking at here? The little kind of legend that I use is the stuff that is inside of slashes is a process. Stuff that is inside parentheses is a condition, like a conditional or a check. And anything that's inside of square brackets is a just like a section. So that's kind of the legend that we have here for what's going on. So we start by logging in, and this is going to be the CLI. We log in from the command line interface, and then we're going to have to authenticate. Now this happens on the server. There are two possibilities once we log in, right? Or we attempt to log in. Either we authenticate, in which case we go this way, or we fail. The password was wrong, the username didn't match, whatever it was, and then we just say login failed. Okay, and that's kind of like, that's the end of the story in terms of the data flow there. But if we did authenticate successfully, so that would be a true rather than a false, then we would get the tasks for the user, right? Whatever the tasks happen to be. Then, once we retrieve them inside of our server code, we have to send them from our server back to the client. And then on the client, we receive the tasks, and at which point we have the ability to do stuff, right? So all this was the retrieve of the CRUD acronym, right? And now that we have the retrieve, we are at the either create, update, or delete components of it. So we have the ability to add a task, edit a task, or delete a task. So what do we do? What is this mess down here? What is post, put, and delete? In fact, this should have been nope, actually that's all good. So there are more than one kind of HTTP method, which we talked a little bit about before, and we'll talk more about them. But HTTP methods are how we send information to the server to determine how it responds. Now, in our last session, we used the requests library to create a GET request. And in fact, I'm going to all caps that GET just to make it even clearer, because that's what we're doing. It's a GET request. So the GET will ask for information and retrieve it. And that's pretty much what we do whenever we're, visiting a website, is we're asking for information from the server provides it. That's an HTTP GET request. But there are other HTTP methods. One of them is POST. POST is sending data to the server. Generally speaking, a POST request happens when you log in, when you fill out a form and hit submit. That's often when you'll see a POST request happen. Now, a POST request is going to be handled differently because it has data coming in the body of the request from the client rather than data coming from the server. And so the server has to have code that handles whatever's in the body of that request. And we'll look at that when we start playing around with our server code. Put is another HTTP method. Put is very similar to POST. They both have data in the request from the client, but put is canonically meant to indicate that we are updating data rather than creating new data. But that's very much about convention, right? I could make a put create new data in my server code, but it's really not a good idea. And then finally we have delete, which, as the name might suggest, indicates that we're going to delete something. Now again, all of these are about request methods. Do you remember when we played with netcat last time, when we actually wrote out the top line of an HTTP header like this? It was get/HTTP 1.1. That indicates to the server what the HTTP method is. Well, I could have put post in there. I could have put in there. I could put delete in there. And depending on how the server is programmed to respond to those different methods, I might have gotten different information back. So we are going to have to handle those methods as well when we write our server code. But notice that from all three of these potential operations, data goes, or information, the request goes back to the server, and then we're going to have some operations in here, right, that handle the delete, the edit, the add, whatever it is. That, for the purposes of this basic flow, I didn't detail. But at the very end, whatever happens, we're going to send the new list of tasks back to the client because they need to have the latest information. So whatever they do, they're going to, once they create the operation, a whole new list of their tasks is going to come down, right? So then we don't have to worry about them being in sync. And we're not working with so much data that's going to be a difficult ask. So we're going to it's a one-directional data flow, right? So we send data here, and then it comes back from the server, and then the client uses the new information from the server for what it can do now. All right. Just a reminder, again, if you have any questions, feel free to ask in the live chat, or if you're watching this later, ask questions in the comments below. I will be happy to answer them. All right. With that, let's talk a little bit about servers. So we're going to be writing our server code using a library called Flask. But before we get into Flask, I want to talk a little bit more about APIs and how they work, and why we're going to be doing it this way. So APIs, or application programming interfaces, are the ways in which software generally talk to each other. So a piece of software advertises its API endpoints, the operations that are possible through the API, and then other programmers write code that connect to those API endpoints in order to get information. And these days, there are a couple of different formats of APIs that are really, really popular. We're going to be using one called a REST, or Representational State Transfer. And what we have to think about very carefully is how we represent our data as it's being sent over the network connection, and what happens when we receive it. If you think about the data types that we talked about in the data model, right? Strings, integers, those generally are pretty easy to represent, right, in like plain text. But a date time, that's a really special object with special methods in Python, and we can't represent it that way. So we're going to have to be a little clever about how we send data over the wire to work with our API. But before we start building our API, I want to show you one that I think it really clarifies what APIs are and how they work. Okay, so I know that I talk a lot about Star Trek on this stream, and I can't help it because that's just me. But this API is Star Wars, and Swappy is just awesome. So what it is an API for getting data about Star Wars. And there are a bunch of different API endpoints on this that are documented, and we'll take a look at the documentation. But let's first look at what happens when we say, let's look for starships. Let's make this request. Okay, let's do starship/9 as it requested. Okay, cool. So we got, I think this is the Death Star. Yeah. So look at this data that came back. And by the way, let's see what happens if we take all of this and just request it raw in the browser. So it has a nice little page for us to do that. We'll see what happens when we do it on the command line as well. But so look at this. Look at the way that the data is structured. This is not Python. It's really important to know that. This is not Python. This is what's called, I'll type this in here just so we can see it. This is known as JSON, or JavaScript Object Notation. JavaScript is really the programming language of the web. And so when we write our code, we're going to have to think a little bit about JSON and how data is represented in JSON so that it can transfer over the web in an easy to understand way. The good news about JSON is that it looks a whole lot like Python dictionaries, right? Look at this. So it starts with the curly brace and then key value pairs, just like we've done with dictionaries in Python. So in fact, the JSON library in Python basically just does this for us. It translates JSON objects like this into Python dictionaries without any fuss or muss. So we're going to be using that in our code. But you can see this idea where, you know, we do the we have this API and then we have an endpoint of /people/ you know, whatever, and that takes us to the very specific endpoint. Now, if I were to look for, let's do this again. So API/starships. This should return the whole smash. Yeah, it does. So what happens if I look for all the ships, right, is I get this a little bit more structured piece of data that tells me this is a page, right, where I have like 36. There is a next page, right? See that page equals 2? That's the link to the second page of the data. And then there's a results. In JavaScript, this is an array, but that square brace in Python should tell us that this is a list. What's it a list of? It's a list of key value pairs, also known as JavaScript objects, but in Python they would be dictionaries. So inside of this results key, we get all of these different objects that we can work with. This is very much how we're going to structure our API for PyTasks. We are going to be able to request, you know, like /tasks, and we're also going to send it some user information, and it's going to retrieve the right users or the right tasks for the user. But it's going to be structured in this way with JavaScript object notation so that it can transfer over the web and then be interpreted not just by Python, but anything that knows how to speak JSON. To accomplish this, we are going to use a very specific library. So we are going to use the Flask web framework, or the Flask web server library for Python. Flask is awesome. There's a lot to it. You can build whole web applications with it, not just APIs. It has all sorts of stuff inside of it that are really, really great for building out solutions. I've used Flask a bunch of times for personal projects and also deployed Flask in production. And it's rock solid if you know what you're doing. So we're going to play with Flask. Luckily, Flask is pre-installed for us on our Replit machines, but there is another piece, there's another application that isn't Python related. It's just going to be helpful that we're going to install in our starter REPL to make our lives easier. Now, this is kind of deep into Linux nerdery, so I apologize, but you're here, so at this point you should probably expect it. And so what we're going to do is we're going to install an application called Tmux. We actually played with Tmux a little bit already last time. If you recall, we were in the Google Cloud Shell and we had reason to have two terminals at the same time when we were playing with Netcat, and we split the terminal screen down the middle and we had a prompt on either side. Tmux is what allowed us to do that, and it's going to be really helpful for us to be able to look at the have the server running in one of those terminal sessions and be able to enter terminal commands in another one at the same time. And so we're going to install Tmux to make that happen. So with all of that, we're pretty much ready to jump into code. So let's start playing with Flask. Let's start playing with Tmux. Okay. The first thing I wanted to show you here is the Flask documentation. There's something about Python libraries. A lot of them have this like really kind of old school aesthetic in their documentation, and I just love it. I just do. It feels very good to me to be looking at documentation like this. I highly recommend flask.palletsprojects.com. If you search for like Flask Python, it'll take you right there. I highly recommend going through at least the quick start of the Flask documentation. And we're going to be taking a look at that a little bit in just a second. There's a lot to read here, but if we do look at Quick Start, for example, what's great about this documentation is how clean it is. And it's not just code examples. Look, it's explaining step by step everything that we're doing. So you really can understand exactly how Flask works. Documentation is often overlooked by projects, and I can't overstate its value. In fact, if you're interested in contributing to open source projects and you don't feel like you're ready to submit code, working on documentation is a great way to start. Because if you understand how something works and it's not explained clearly in writing, and you can do that, it's a massive help to the project. All right, let's head over into Replit here, and let's get out of the diagram. We'll bring back our terminal a little bit. And let's enter a bash shell, a proper bash shell, by typing bash in here. Okay, I need to install Tmux, so it doesn't come preloaded on here. So in order to do that, I'm going to use Replit's own package manager. We used the apt application on the Google Cloud Shell last time, but apt is not available to us here because we don't have those sudo powers, right? We don't have admin privileges. But luckily, Replit understood that we were at some point going to have to install applications, so it gave us install-pkg. And so we're just going to run install-pkg tmux. And that's going to go ahead and do some of the same things, right? It goes out to the repositories that the Linux computer is configured to connect to and download the latest catalogs of software, find the Tmux package, download it, and then run the installation. Now, once it's done, I'm going to type clear and just bring my terminal back up to the top. And then I'm going to type Tmux. Okay, so a couple of things just changed about my terminal. First of all, I lost the coloring in my command prompt, but I gained this green thing down at the bottom. What do I have here? So with Tmux, I can create in my Tmux session, I can create multiple terminal windows. I can create windows and panes. So what is a window? The important shortcut that you need to remember for Tmux is Control B. and it's Control B whether you're on a Mac or a Windows computer. So Control B, and then if I type C, notice that I now have 2 of these things down here. Oh, did my replit just disconnect? Oh, cool, came back. And my Tmux session is up. That's great. So let's type something. Yeah, let's run bash in here. So if I type something in here, it's nonsense. I'm just going to type it in here. Just to show you that if I do Control B and then 0 to take me back to my first window, oops, Control B, 0. What's going on here? Oh, did I lose Tmux? Is it gone? Oh, it uninstalled. That sucks. When the replit reloaded, it uninstalled Tmux. So let me just grab it again. That is something that's kind of annoying. If you don't have, anything that's not in the files folder here is going to be blown away every time you restart your REPL. So installed applications, for example, don't work like that. So let me run Tmux again. Okay, Control B, C for creates a new window, and like here's some nonsense. And notice the little star, I'm on window 1. If I do Control B and 0, it takes me back to Windows 0. And I can rename them too. Control B, comma allows me to rename stuff. So for example, I could name this server, and then Control B1, Control B, comma, and I can say, okay, this is like code, whatever it is. Control BX removes windows or panes. Type yes, and it gets rid of it. And then lastly, and this is the part that we're actually going to play with, Control B and then double quotes, so shift and then the apostrophe key, splits the window horizontally. And then Control BX does the same thing, right? If I kill that. And then if I wanted to split vertically, Control B %, does it that way. Okay, that was a lot, I know, but just something to know as we go through this, that it's going to be handy to have Tmux up as we write our server code. Let's write some server code. So the first thing we're going to do is we're going to make our server file, and for ease, we're going to call it app.py. There's a reason for that, which is that Flask, by default, when we run Flask, it is going to ask for a file called app.py. Let's see if Flask is even installed. Okay, so it is, which is great news. It gave us a bunch of errors because we didn't use it correctly, but Flask is installed, so we don't have to install Flask. All right, what does our starter code look like for Flask? Let's start with we won't be writing the PyTasks code just yet. We're going to start with just like a hello world Flask app. So we're going to do from Flask import Flask. Nope, should be capital F. This might seem a little bit funky. So we're saying from the Flask library, we're going to import the Flask class is actually what we're importing. Okay. And then we're going to say app equals, so we're going to start our app and we're going to initialize it with the built-in name. This is some Python funkiness. We've seen double underscores before when we wrote the like str method to print stuff out. Basically, what this is saying is that when Flask runs this Python program, we're going to make an app with the default name that is attached to this file. don't worry too, I hate saying this, but don't worry too much about this right now. It is just a safety catch to make sure that Flask runs the way that we would expect it. Okay, now it's time to build out our routing for the application. To do routing, Flask uses decorators. And we've seen decorators before. We've seen decorators when we did static method and class method when we were working with classes. It is a way for Python to interpret the code below it and how to use it. So in Flask, decorators are used the following way. To create a new route for, let's say, the root of our web server, which would be just the / without anything, we're going to do this. app.route, and then in quotes, the route that we're going to be handling. In this case, it's going to be a / right underneath of it. Okay, because this is a decorator for the thing. We write the function that is going to execute and return data when this route is accessed. So we write the function. Let's do just hello. And we're going to return hello from Flask. That's it for now. That's it for now. Let's go ahead and, just as a safety measure, in our main.sh, let's change this to do Flask run, because that's the command that we would actually enter to run the Flask server. Okay, but we are going to manually hit Flask run right here. And in fact, let's go ahead and use Tmux to split our screen so that we can do it with while still maintaining our command prompt. So Control B and double quotes to get two different windows, and then Control B and then the arrow keys to navigate between them. So that green line here is on the left, which indicates I'm currently on the top window. So I'm going to run Flask run. Okay, so forgot something really important. Let's Control C to stop it, and then let's do Flask run --help. Okay, and let me scroll that up a little bit so we can see what we're doing. I totally forgot something super important. By default, when Flask runs, it runs on this special IP address. This is why we talked about networking last time. It runs on this special IP address, which you may remember is the magic IP address that is the local computer, 127.0.0.1. Now, when you bind a server to listen on that address, the computer doesn't accept data from other computers. It's just local. So let me show you what I mean. If I do Flask run just the way that I did, see how I have this address here? If I try to go here, I'm not going to get anything. But if I use this this bottom command prompt, and I go to this, I use curl, or I don't have curl on here, do I? I'll do, I'll try wget to see if that works. http://127.0.0.0.1. Wow. Port 5000, and that's how we indicate ports in URLs, with that colon. Look at that. So wget did a couple of things. It downloaded it and saved the file to index.html. That's a default behavior for wget. It's not, though. If we open that file, what do you think is going to be there? Hey, it's the message that we told the server to send. So we're going to remove that file. I don't need that file. But okay, so the server's working, right? But it doesn't work for the general internet. So we have to change the way that we start Flask. So let's Control C to stop it. Instead of Flask run, we're going to tell Flask to run with the -H option. And the host that we're going to bind to is 0.0.0.0, which is basically saying, hey, listen on every network interface you got. If you have a loopback, you're going to listen on that, but you're also going to listen for external communications. Now, what should happen when I do this is that Replit should detect that there's a server listening on this REPL and pop up a little web browser that gives me a response. So let's see what happens. I love it when things work. It's a great feeling. So notice that we get the message back, right? So our server is working. Congratulations, you just wrote your first web server. Your server is working. And also notice that you have information from the server about where the data came from. Right, 172.18.0.1 is the IP address that accessed the local server. Now, if you recall, that's actually kind of fake. That's kind of the way that Replit's network architecture is designed. They have kind of a front end that is sending the traffic to you. So you're not looking at people's real IP addresses in Replit this way. Okay, but this is great news. So our server is working, and let's go ahead and close out the web view. And let's also close out this server here. And let's close out this pane. I want to okay, I don't know why these are just so tiny, but let's make them bigger. Okay. Well, it is what it is. So now let's talk a little bit more about different kinds of routes that we can create. For example, let's see if we can handle parameters inside of our path. So let's try to give it a name. So we can do like a hello world with a name, the way that we did for our original hello world. To do that, we're going to make another app.route decorator. And this one's going to look a little bit different. It's going to be / and then in brackets, sorry. I can't remember what I'm supposed to call these. Yeah, no, they're brackets because these are braces. So in brackets, we're going to do name. This tells Flask that this is going to be a parameter that we are expecting, and we're going to make available to the responding function. So when we write this, let's write greet. Greet now takes an argument called name, which we're going to be sending in from this information. And then let's do very much what we've done before, right? We're going to do return hello right? And remember .format. Like so. All right, let's rerun the server. Oh, it doesn't give me the web view back. That's cool. But no worries, because now I should be able to get to it this way. Yeah, no. Annoying. Okay, let me just reload the REPL here then. And we'll run it the other way. This is one of these shortcomings of working in a purely cloud environment where you don't have all the tools that you would necessarily have in the Okay, let's try this again. Okay, let's reload this. So we got hello from Flask. So this part is working. Awesome. Now let's edit. Sorry, let's open this in a new tab. Great. Now let's do a / and then say Taggart. So check that out. I am sending URL parameters down into my request, and the response is responding appropriately. So that is how we handle that. All right, let's close this out and then come back over here. Control C to stop the server. And by the way, anytime you make changes to the code here, you're going to have to restart the server. All right, we have a little bit of time left before the end of the hour. Let's go ahead and start building our Flask server, our task server that we're going to use, and we're going to use it the way that we would actually use it. Let's start with all of this is pretty much going to be the same, but we also know that we're going to want to save the tasks, right? Well, where are we going to save it? For now, we're going to save it in a JSON file, and in the code, it's going to be represented as a list of some sort. So we know we're going to save it in a file, so let's define that file like so. Tasks file equals tasks.json. Okay. So when the server first starts up, it has to load that data, whatever's stored in there. It has to load it. But right now, if it were to attempt that, it would fail. So luckily, we know how to handle problems like that. We're going to use a try and except block to attempt to load the file and otherwise just make it an empty list. Like so. So we're going to do try, and then we have that cool with open syntax that allows us to quickly open and close files as necessary. So we're going to do with open tasks file as f, remember that colon. And then we're going to do tasks. Ooh, I forgot something important. We also have to import the JSON library because we need that to load the JSON data that's going to be in there. So tasks equals JSON dot, feel free to autocomplete, no. Load is the method that we want, and we're going to load the file in. That loads the JSON data appropriately from the file object. Okay, now this might fail because the file doesn't exist, right? So if it fails, we're going to write an except, and at that point, tasks equals just an empty list. All right, and we have our app initialization. That's all looking good. Now we would actually come down into our app routing. Okay, so the first route we're going to do, we're not going to do a root, for example. We're going to do just /tasks just to start, to give you an idea of how we're going to build out the API. So /tasks is going to we're going to do def get tasks. Actually, I'm going to call this the tasks router. You'll see why in just a second. Now, to start, we're going to just return tasks. Okay. And let's go ahead and clear out this /name route. We're not actually going to use that. Okay, let's go ahead and rerun our server and see what happens. So we're going to do Flask run. Okay, and let's go ahead and open this in a new tab. Now I get a 404 or a not found because I didn't do anything in route. And we'll learn about redirects later, but let's go ahead and do /tasks. Okay, so I got a 500 or an internal server error. Let's see why. Let's see. The view function did not return a valid response. The return type must be a string, dict, tuple, response instance, but it was a list. Okay. So we have to structure the data a little bit. We can do this a bunch of different ways. To start, we're going to use the JSON.dump or dump_s method. So what JSON.dump_s does is it takes a Python object and returns the JSON representation of it. So in this case, that would be in a string. So that should send us JSON. Let's go ahead and run that. Okay, and let's try this one more time. Cool, check it out. We got an empty list. It's not the most exciting, but it's a start. Now let's say I wanted to be able to actually add a task. Let's stop our server again. Well, we know from our diagram that adding a task is going to be not a GET request. Sorry about that. Not a GET request, but a POST request, right? So to handle that, we are going to have to write a handler for not just a GET request here, but a POST request. To do that, we're going to have to import a couple of other things from Flask, not just the Flask main class, but also a few helper functions, including request and make response. These are going to be handy when we actually go and send responses appropriately. Okay. Let's first write a function off of the decorator called addTask. And addTask is going to take a single argument of rec, R-E-Q, for request. So there's going to be something in the body of the request. Now, hopefully, the data is structured appropriately, and it will be JSON data that we're sending. Now, if we look at the Flask documentation for requests, let's go ahead and find that. The request object. So here's everything that the request object can do. Oh, come on. Okay, I want request, and then I want request dot. Should have JSON in here somewhere. Like I definitely know it does. Okay, well, our request has this JSON method in it. And so what we're going to, or this property, which goes in, like by default goes and gets our JSON. So what we're going to do is we're going to use that in our code to access JSON in our request body. So we're going to say data equals rec.json. And then we're going to, so that's the new task that we're going to append. Now we haven't structured any of this yet. We haven't worked with our data model or anything. We're just going to see if we can receive data and handle it. So the data, what we have to do, right, it can't just be this like object like this. I mean, it can be, but there may be other ways we want to structure it. So inside of the JSON object, it's going to actually look a little bit like task, because there may be other metadata that we want to send in. So it's going to have a task key and then the task object itself. So this becomes a Python dictionary once it's inside. So if we wanted to access the task key inside of our data, it would be like this, data and then task, like so. So what are we going to do with it? Well, we're actually, first, we're going to append it to our list of tasks, tasks.append data and then task. Now we have another problem. We'll go ahead and print tasks out to our console, but we also have to write the new data. Let's make that a different function as well. We'll kind of call our shot with save tasks and send the tasks in here like that. And then def save tasks. Well, tasks is global, so let's not do that. Okay. Do it this way. Great. So what we're going to do here is with open tasks file, and then we're going to open it in write mode as f. Do the same thing, json.dump, not dump s, because we're dumping the actual data, not a string representation of it, to the file. So dumping tasks to f. Okay. And then we're going to return, let's just return success for now. Now this is why we call this the tasks router, because we're going to be handling the kinds of methods that it is allowed to work with. So we actually add another parameter to our decorator here, which is methods equals, and then in a list, the methods that it's allowed to handle. So at the moment, we're doing get and we're doing post. Now, this is where we handle the get post routing. If request, that's why we imported this here. If request.method equals post, we're going to return add task, and we're going to send the request in there. And we know that we don't need the else, but we're going to put the else in here. So otherwise, we're going to return just the JSON representation of the tasks. All right. So we have our router that handles the post request and sends that information to add tasks. We have the default get request handled as well. And then we're going to save the tasks, which hopefully when we run this appropriately, will go ahead and create the task file. All right, let's rerun this and see what we can do. All right. And okay, so I'm still getting tasks. This is working. Now, how do I do a post request? So for this, I'm actually going to fire up my Google Cloud Shell because it has an application that Replit doesn't let me use, which is curl. We installed curl before, or no, we didn't. We didn't install in Replit. We used it from Google Cloud Shell, which is what we're doing now. So I'm firing up my Cloud Shell. And opening in a new tab. So let's first confirm that my Cloud Shell can talk to this server. So I'm just going to do curl and then that URL. And you can see that I did get the empty list back, so that's all good. So now I'm going to change the method. By default, curl uses get, but I'm going to use the -x option to change it to post. And then I'm also going to send some data with the -d, and then I'm just going to send an empty JSON object. Actually, you know what? I'm not going to do that. I'm going to send tasks, or task rather, and then inside of that, the empty object. Let's see how that goes. Notice that I'm being very careful about quotes here. Okay, so I did something wrong. But we got our different response, right? We got a 500. Now let's see what happened over in Replit. Okay, so none type object is not subscriptable. So it didn't see the data. So what we're going to do, just as a safety, is we're going to print the data just to see what it looks like when we get it. All right, server's back and running. Back over on my Cloud Shell, I'm going to do the same thing. Okay, so it could not see any JSON at all, right? Nothing got printed out. Or actually, yeah, see, none. And the reason for this is that, again, this is much easier to do when we're not doing it on the command line, when we're doing it through a web browser or through a proper, application. The reason there was no JSON is because we didn't tell the server that it's JSON at all. To do that, we also have to add a header with the -h, and then it's going to look like this: content-type application/JSON. So this whole thing is how we send that data. So let's give that a shot. Okay, so that was a 400, which is a little bit better. It's a different kind of error. Let's see what we've got in Replit this time. Okay, so that was just a 400. We didn't get any data though. So let's try to modify the. This is probably part of the reason. Formatting JSON this way is a little bit annoying. So I'm just going to send it an empty JSON object. Oh, we're back to 500. Okay, but now we're getting a key error. meaning that there was no task in there. So let's see what we got here. Notice that this time we got an empty object. So we have JSON communication working. It's just that there was no task in there, which, by the way, this should have a try except around it, right? We should have a try in this, like all of this, and then there should be an accept. The return success should be in there as well. And then the accept, we're going to say return failed. There's another way to do this, but for now, this is where we're gonna leave it. Okay, so we have to be a little bit more careful about how we handle our JSON formatting from curl. And yes, there are other ways to do this, but I want to show you how curl works. So let's do it this time with escaped. Let's do it this time with escaped quotes. All right, let's try that one. Success. So it doesn't like single quotes. How annoying is that? You have to do escape, so backslash double quotes to do this. Now, I should make mention that this is a very command liney way of doing it. There are lots of tools that can help you do it, and one of my personal favorites is, believe it or not a command line application. It's Postman. Yeah. So this application it's awesome, and it allows you to test APIs by structuring your API request, and it's kind of saving the different versions of your request so you can test and do all sorts of cool stuff with it. Anyway, postman.com if you're interested in checking that out. But now that we had a success here, let's go check out what happened on our server. Okay, so first of all, our data got printed out and then saved our tasks. And look, now we have tasks.json. And inside of it is an empty list with an empty dictionary inside of it, which isn't really what we want. We want to be able to save, we want to be able to save real data, but it's a start. Now, last thing I want to show you is how we handle, let's stop the server, how we handle errors and successes appropriately. And that's why we imported make response here. So first of all, make response it takes a tuple as an argument, which is the message or the body of the response, and then the status code. HTTP status codes, you can look them up. We've seen some of them, like 400, 500, 404, give an indication of what happened with the transaction. So make response for a success would be the message success and then 200. Now, as a matter of fact, what we actually want to send back is the tasks. But for now, we're just going to send back success because we don't have to send the tasks. Let's send the tasks. So we'll do json.dump s tasks. Okay. And then if it's a failure, we do make response json, nope, just failed. And then the error code is going to be 500, which we were getting before, but we were getting it kind of unstructured. Okay. Now let's see what the difference looks like there. Okay, now by the way, when this loads, tasks already has an empty object in it now because we were able to load the file. So we should get different stuff back when we ask for it. And indeed we do, right? We see that empty object in there. Now, from our Cloud Shell, let's create a new empty object. And now, instead of getting just a success back, look, we got the tasks back. And this is the flow, right, of sending and then getting the new data back. So we already have that going on. Now let's send bad data. Right, now it just says failed. Okay. I think that's a good place to stop it. Let's Control-C to stop our server. All right, that was a lot, but we now have a working web server that is sending API data and accepting new API data. We have a lot to do to clean it up and make it work the way that we actually want it to for our task server, but we're off to a great start. We have an understanding of the data flow. We have an understanding of the data model, which we still have to build out, but we're going to get there. And we made our first web server today, so congratulations. This is a great first session for building PyTasks. So we're going to get out of here for today, but before we go, if you're enjoying what we're doing and you feel like giving back in some way, I highly recommend checking out Human IT. They are a nonprofit organization that is providing low-cost internet connection and computing devices to families in need. Just yesterday, I saw a picture of a couple of little girls who were on the curb at a drive-thru of a Taco Bell with their Chromebooks and some homework, trying to get their Wi-Fi because they didn't have Wi-Fi at home. With students outside of school buildings, but still trying to learn across the world, but certainly here in the United States, there are lots of families who could use your help. And Human IT is trying to connect lightly used computing devices and financial contributions with the folks who really need it. So if you feel like contributing to that effort, please visit them at humanit.org and see if you can help. That's going to be it for this week. Thank you so much for joining us. Next week, we're going to continue building our task server, and we're going to talk a little bit about our data model and how we represent it in classes. We may also, if we have time, get into the client side of our code. So that's it for this week. Thank you so much for joining us. Happy hacking.